Introduction. Residential areas and business in river floodplains are susceptible to flood. The link between flood discharge and rainfall cannot be overstated scientifically and practically. Rainfall to flood has conversion use a rational formula. Assuming constant event runoff coefficient and routing, flood plate distribution function and rainfall intensity distribution function are proportional. Variable cause flood frequency distribution to diverge from rainfall distribution for real storm and catchment. Floods are caused by heavy rains. Extremely heavy precipitation dispersal is influenced by the local climate. Analyze hourly and daily range gauge data from a range of climate locations show a positive relationship between the expected value and annual rainfall. This study evaluates using a runoff and rainfall data how rainfall processes and catchment area characteristics affect the risk of flooding. The investigation used data from Johor rain and runoff sensor.
Hai, Assalamualaikum warahmatullahi wabarakatuh. So my name is Awinur Hakimah binti Abdul Halim with metric number AF190272. I'm going to present about methodology and analysis. Analysis in other video. So the first is flowchart of our methodology. So first we choose the area and then we collect the data collection and then data analysis and then we conclude it. So first is selection of study location. So each group must choose a Malaysian state with 3 locations for rainfall data and 1 location for water level data. And so we choose in the area Johor Bahru. So we look at Kampung Pelentong Baru, Kampung Sri Pandan, and Sungai Tiram in Ulu Tiram. So this location share a catchment area. So for collecting data, we use the Department of Irrigation and Drainage DID is in charge of managing Malaysia water resource and encourage the best of possible land use for environmental sustainability and water security. So using the DID website, all the information about rainwater levels and flood warning can be obtained by the following links. So the use of Google Earth Pro software. So by this software, it allows us to learn about the area that frequently flood in our area, the terrain profile and gradient slope between station, and the portion of the river that cross at the selection water level. So to find out the rainfall data, we have 3 methods. First method is the arithmetic mean method, and then the next one is the thesis polygon method, and last but not least is the isohedral method. So water level data. So the height of the water surface above a datum is measured to determine a river stage. So the mean sea level MS or any other arbitrary datum that is in to the MS can serve as this datum. So calculation of peak flow using rational methods. So the formula known as rational method can be used to calculate the maximum runoff discharge from a catchment of a specific location.
Hi, Assalamualaikum. I am Muhammad Mariza bin Muhammad Rizwan. I am presenting the use of Google Earth Pro software. So for the Google Earth Pro, download a GIS allows for the visualization, evaluation, overlay and creation of geospatial data. This user-friendly tool is beneficial for beginners who wish to learn the fundamental of GIS. Google Earth Pro utilizes the imagery of Google Earth. Google Earth Pro provides business-oriented tools such as the ability to create animation videos and measure polygon or circle areas. This software was a key component in our research since it allowed us to obtain information about the area of common flood of your location, the terrain profiles and gradient slope between stations, and lastly the cross-section of the river near to the chosen water level.
A hydrograph is a graph or plot that shows the rate of water flow in relation to time, given a specific point or cross-section. These graphs are often used to evaluate stormwater runoff on a particular site considering a development project. In this project, we will have hydrograph on rainfall station data and water level data. This is the hydrograph for rainfall station Sungai Tiram at Ulu Tiram. This is the hydrograph of rainfall station at Kampung Pelentong Baru. This is the hydrograph of rainfall station at Kampung Sri Pandan. This is the hydrograph of water level at Ulu Tiram.
Analysis and result. Mean area rainfall. There are three methods to find mean area rainfall, which we have arithmetic mean method, Tyson polygon method, and isohaton method. This table show our 7-day collected data rainfall at Kampung Pelentong Baru, Kampung Seri Pandan, and Ulu Tiram. Arithmetic mean method. For the arithmetic mean method, we will have to use the 7-day collected data rainfall to be used into the formula, and then we will get the average precipitation depth, which is 39.17 millimeter. Tyson polygon method. For Tyson polygon method, we will have to divide our station into 3 polygon, which in each polygon will have their own station, and then by using Google Earth Pro, we will get their area, and then based on the data analysis we will use it into the formula, and then we will got the solution, which is P equal to 160.23. Isohaton method. For isohaton method, based on the station we choose, we will have to divide them into the small parts like the picture shown, and then we will have to find the area for each part. Then based on the area, we will put it into the table, and then we will get the data analysis for this method, and then we will put it into the formula, and then we will get that the solution, which is P equal to 24.32.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Usman and my wicket number is AF176. So now I will explain about the rational method. So this is our catchment area, which is at Sungai Tiram. So the measurement of our catchment area is 190 hectare and 7736 meter for our perimeter. For the average rainfall intensity, we will use this equation, and we will refer the Johor Silica as our station name. So for the average rainfall intensity, we will get 64.5264 mm per hour. So next we will calculate the water flow. We will use the equation Q equals to CIA, where the runoff coefficient we use the 0.4 for the forest cover, and the area catchment is 190 hectare. So the water flow we will get is 13.622 meter cube square. The ARI 20 years for Johor Silica, we will get 64.5264 mm per hour. Then we will calculate the peak discharge for each station. For the station at Kampung Pelentong Baru, we will get 6.166 meter cube per second. For the station at Kampung Seri Pandan, we will get 9.88 meter cube per second. Then for the station at station Ulu Tiram, the ARI 20 years, we will get 384.43 meter cube per second. So next is cross-section profile. We have 3 cross-section profile. For the first cross-section, the perimeter is 111 meter and the area is 1312 meters square. We calculate the water flow, which is 119,322.61 meter cube per second. For the second cross-section profile, the perimeter is 35.2 meter and the area is 138.5 meter square. The slope is 88.9. So the water flow is 26,016.71 meter cube per second. For the last cross-section profile, the perimeter is 241 meter. The area is 1,832 meter square. The slope is 0.7. So the calculation for water flow is 47399.48 meter cube per second.
Analysis. So for analysis, the cross-section performatic discharge result and the resolution discharge result are in conflicts. So the study may lead us to the conclude that rational method is more precise than the cross-section profile methods. The reason for this is the cross-section method determine the head of or stage of the stream surface before calculating the mean velocity of the water flowing through the stream channel and finally calculating the derivative of a known relationship between stage and the total volume of result. So the result of this method may be average, and the rational method for project can be accurate because it doesn't exist to 100 accurate due to the volume of our catchment area for being 190 hectares.
Conclusion. Malaysia is one of the countries with the most yearly precipitation with about 2,500 millimeters. Continued expansion of densely populated floodplains, encroachment on flood-prone area, forest degradation and hill slope development, people have chosen to ignore the harmful effect of pure severe floods induced by rapid development and environmental damage in favour of prospering economy. In the backdrop of extant economic prosperity, it's reasonable that politicians and Malaysians from all walks of life would be more concerned with a strong economy than floods. According to the study, the government flood management strategy are largely engineering-based and inadequate for monsoon floods. Malaysia must upgrade its disaster preparedness system to lessen the severity of flooding induced by changing climate trends. That's all from our group. Thank you.